into 10 power 5. Here Reynolds number equal to 5 into 10 power 5, it is greater than 5 into 10 flow through the plate. Should remember while solving the numericals. Next slide. Next slide. So let me see the assessment in this laminar and turbulent flow. Which of the following factor primarily decide whether the flow in a circular pipe is laminar or turbulent? So which number decides? Already we know that Prandtl number no, pressure gradient no, dynamic viscosity no, Reynolds number. Reynolds number is the parameter or number which decides whether the flow is laminar or turbulent. This is the repeated question asked in end semester also. Just remember it. So the next question is, the flow through a circular pipe is laminar. Now the fluid through the pipe is replaced with a more viscous fluid and passed through the pipe again with the same velocity. What can we say about the nature of this flow? So the flow will become turbulent. The flow will be a transient flow. The flow will remain laminar. Reynolds number of the earlier flow is required to answer this question. So the flow will remain laminar because the flow through the circular pipe is laminar. Now the fluid through the pipe is replaced with a more viscous fluid. Viscous force is related with the laminar flow. Already we have discussed. We are mapping it. That's all. Next question. So here the question is, how is Reynolds number defined as? So we know that viscous force to the inertia force to the viscous force. So that is the answer. Inertia force to the viscous force. So there is several answers given. We need not confuse. We got the answer. The ratio of inertia force to the viscous force is nothing but the Reynolds number. Next. Which of the following flow has the highest critical Reynolds number? That is lower. Flow in a pipe, flow between parallel plates, flow in a open channel, flow around a spherical body. Flow in a pipe having the higher critical Reynolds number, the lower Reynolds number, when the fluid is flowing through the pipe, which can be experienced. That is a very important concept. Next slide. So assessment, fifth question is fill up the blanks. Capillary tube method of viscosity measurement is based on the capillary. You know that when the fluid is rising in a pipe, that is due to the action of capillary. One meniscus joined with another meniscus and rising up in a pipe, in a tube, both the way. So the first answer is Huygens-Poiseuille equation. Second is Stokes law. Third is Navier-Stokes equation. Fourth is none of these. So the capillary is related with the Poiseuille equation that already we seen in the derivation part. So that is nothing but Huygens-Poiseuille equation. Next slide. So these are the web references. Just use the Banzal, which is having the lot of material in the new version, having the objective type question, which is suitable for preparing the gate examination, which is suitable for attending any quantitative methods of examination, any aptitude examination. Next is Rajput. This is also a very wonderful book. Both are Indian authors. They have deliberated in different way of approach. You can refer both the books for gate preparation, and both the books has the colored representation of sketches and equation, weighted equations. So you can prepare very easily. At the end, there will be objective type question. That objective type question also very easily preparable. Next slide. So go to the beginning, previous slide. Previous. Go to the slide number 10. Okay. So here ratio of inertia force to the viscous force that we know. Previous slide. Previous. Next slide. So this formula is very weighted equation for flow through pipe. When the fluid is flowing through the pipe, it is Reynolds number is less than 2100 for the laminar flow. Where when the fluid is flowing over the plate, the Reynolds number is 5 into 10 power 5. 5 into 10 power 5. For the same case, when the fluid is flowing through the pipe, the fluid is flowing through the pipe when Reynolds number is greater than 4000, it is said to be a turbulent flow. When the fluid is flowing through over the plate, the turbulent flow, that is Reynolds number greater than 5 into 10 power 5. So with this, I conclude this session. Thank you.